pyramids, and they're these little triangular, the pink triangular things. So all these are pyramids. And the pyramids end in a point, and that's called the renal papilla. So each little point at the bottom of the pyramid is a papilla. Coming out of the papilla, and I'm going to go a little bit out of order from the lab book because I think the lab book is maybe not in the best order, but coming straight off the papilla is a small tube called the minor calyx. So each little tube coming off a renal papilla is a minor calyx. So all these little tubes are minor calyces. Then when a few minor calyces join together, you have a major calyx right there, or right here is a major calyx. And then when the major calyces join together, that's the renal pelvis. And the renal pelvis goes out to the hilus, and then starts to head down toward the bladder, and now it's called the ureter. Cortical nephrons and juxtamedullary nephrons, those would be questions. A cortical nephron has a short loop of Henle that doesn't go deep into the medulla, so its loop of Henle would be kind of up here. And a juxtamedullary nephron has a really long loop of Henle that would dip down way into the medulla. Okay, so let's switch over to this model, which is pretty much the same as that one, just kind of all spread out. So the kidney with the cortex out here, the medulla on the inside with the pyramids, the renal capsule on the outside, the papillae of the pyramids, minor calyx, all these are minor calyces, and a major calyx, another major calyx, and they come together to form the renal pelvis. They go out through the hilus and become the ureter. For the nephron starts with the renal corpuscle, which is the glomerulus plus the Bowman's capsule. So if you look at this side of it, this ball of capillaries is the glomerulus, and it's surrounded by the Bowman's capsule, and all together it's the renal corpuscle. When you look on here, anywhere you see a red ball, that's going to be the glomerulus. So right here, teeny, tiny little red balls, they're all glomeruli. So anywhere you see a little red ball, it's the glomerulus. Coming out of the glomerulus, if you look at this side of it, you've got the glomerulus. That leads into the proximal convoluted tubule. And then once that starts to go down, that's the loop of Henle. We have the descending limb of the loop of Henle. And then when it goes back up, it's the ascending limb of the loop of Henle. And then when it starts getting all twisted again, now it's in the distal convoluted tubule. And then finally, the collecting duct comes out here. Hold on to the macula densa for a second. We'll worry about that in a minute. For the blood vessels, the renal artery is the red one. Then going up here is the segmental artery. And then we have interlobar arteries that go between the pyramids. And then arcuate arteries. The arcuate arteries are the ones that separate the cortex from the medulla. And then the cortical radiate arteries are the ones that radiate throughout the cortex. And they lead to the afferent arteriole, which is really teeny tiny right there. So if you imagine me with a piece of masking tape trying to point at that, that's not going to happen. I'll do it somewhere bigger, like right here, where this is a big old afferent arteriole going into the glomerulus. And then the efferent arteriole is this one behind it. The veins are named exactly the same as the arteries. So the renal vein, the arcuate vein is right there. Now if you look over here at this model here is just taking like a little square right here and blowing it up. So we've got the arcuate artery and the arcuate vein, cortical radiate artery, cortical radiate vein, and then the glomeruli. And that's it. For peritubular capillaries, that'll be a question. There is one model where you can see them, but it's really difficult to point to on a test, so I'll ask it as a question. the capillaries that surround the entire renal tubule. Vasa recta, same thing, there isn't really a good model of it, so it would be a question. It's an artery that runs parallel or to the lymphopendling. Okay, now this model here is the same as the one on the right that we saw just a minute ago, where you have the glomerulus and the afferent arteriole. The efferent arteriole now has this purple one, and then the Bowman's capsule is here. The proximal convoluted tubule coming off of it. So far that's everything that we could see on the other one. But it does add in this group of cells and this group of cells. Together, they're called the juxtaglomerular apparatus. The cells in the afferent arteriole are the part of the juxtaglomerular apparatus called the juxtaglomerular cells. And then these cells are part of the distal convoluted tubule, and they're called the macula densa. So I would ask either one of those here, or I may say, what are the two components of the juxtaglomerular apparatus? It would be the juxtaglomerular cells and the macula densa. Okay, so that's it for that model.